I am Muhammad Usman and today we will discuss Introduction to Statistics. It shows that statistics is a tool which transform the data into information, or you can say that it is basically an art of extracting information from data. And what is data? Data is facts, figures, numerical facts and figures which have been collected together for reference or information. And what is information? It is communicated concerning some particular facts that you have extracted from the data. So this is basically a very basic definition of statistics. Why we study statistics? Data is everywhere, in every field. Wherever you go, you will find data. And then statistical techniques are used to make many decisions that affect our lives. Therefore, we study statistics. And here is the brief history in this slide. You can see about statistics that in 1662, John Grant published statistical information about births and deaths, and then that was basically very early days of statistics. And then later on, households, government, business rely heavily on statistics data for guidance. And today, in modern age, we calculate unemployment rates, inflation rates, consumer index, birth and death rates, and carefully combine all those data and we use that information for certain planning purposes. Therefore, this is the brief history of statistics. And now we'll come to the definition of statistics. First of all, as I have already discussed that you have to convert your data into the information, or you have to transform it into a meaningful information, and for that purpose you have to collect the data. And once you collect it, you need to process it, summarize it and analyze it before actually presenting it. Another way we can also explain statistics as the study of variability. No two objects in the universe are exactly alike. So therefore, variability exists in every field. And when it exists in every field, you need to study that. And the last, we can also associate statistics with uncertainty. Uncertainty is everywhere, and perhaps the statistics is the only subject which deals with variability and uncertainty. And now we will discuss a very core concept of population and sample. Population is the entire group under observation, under investigation, whereas the sample is a part of population. Rather, we can say it is a representative part of population. And the quantities computed from population are known as parameters, or we can say population parameters, whereas such numerical quantities computed from the sample are known as sample statistic. In this slide, we'll discuss the two branches of statistics. The one is called descriptive, another one is inferential. Descriptive involves summarization and display of data into tables, graphs and summary numbers, whereas inferential statistics deals with methods involved to draw inference about the population based on the information contained in your sample. So you can say that if you just describe your results, that is descriptive statistics, whereas if you want to draw inference about the population based on your sample result, that will be known as inferential statistics. And now we will discuss a few types of a variable. First of all, we need to define what is variable. So any characteristics that varies from object to object, place to place, or over time is known as variable, like marks, age, height, sex, temperature, scale, revenue, time, and there could be many examples. And there are broadly two types of variables we have. One is quantitative, the other one is qualitative. That quantitative variable have further two types. One is discrete and the other one is continuous. Well, coming back to the qualitative variable, we can define it like this is the characteristics which varies in quality. So it is not numerical, first of all. And few examples of the qualitative variable are eye color, sex, male or female, education level, you may be graduate or you may be undergraduate, and the behavior, that may be good or bad or fair. Similarly is the variable in which you can quantify your variable. It is basically accounting. See the number of examples. The variable which can assume specific value within the given interval. Mostly these are counting. Like for example, number of students, number of chairs, number of deaths in a certain hospital, number of births, number of road accidents on a certain road in a certain city, and so on and so forth. And the last one is continuous, the most widely used. These are the measurements. Or we can say that a variable which can assume any value within the given interval is known as continuous variable. Few examples includes height, weight, height of a plant, weight of grains from a certain plot, marks of a student, time, distance, temperature, all are example of continuous variable. And at the last we will discuss measurement scale, the important topic of measurement scales. These measurement scales were proposed by Stanley Steven in 1951, a psychologist. So before going to explain the measurement scales, we will just define what is measurement. And the measurement is process of assigning numbers or labels to objects, persons, states or events in accordance with specifically logically accepted rules for representing quantities or qualities of attributes or characteristics. There are four types of measurement scales. The first one is nominal, perhaps the most weakest measurement. These are the labels, or we can say that a mutually exclusive categories where order of the categories is not important. For example, sex, male or female, religion, you may be a Muslim or maybe a Christian. The order is not important. The marital status, political affiliation, eye color, the categorical variable in which categories are not ordered, or you can say the order of the categories, they are not important. In ordinal scale, this is better than nominal. It is again a qualitative. In this one, the categories, they have a meaningful order. For example, you can see in your slide, a variable is measured in 5 categories starting from poor to excellent. In this, you can say that very good is better than good, and good is better than fair, and excellent is better from all those. So there's a natural order exists in these categories. If this is the case, then your variable is ordinal, then your measurement is ordinal rather. The few examples of ordinal variable is cricket team standing in the ICC ranking, or the student grades, the students standing in the class, the first three positions. The first position is better than second, and the second position is better than third. There is natural order in that, so there is an ordinal variable. The third type is interval scale. We have quoted an example of cricket team rankings in ordinal scale, where I said that team A is better than team B, and then team B is better than team C. But the interval size is not constant here. For example, the student who stood first in the class and the student who stood second in the class, there might be some difference in marks, and that difference is not supposed to be the same for the student who stood second and the student who stood third. So if that interval is also constant, then your scale is interval scale. But it has one drawback, that there is no true 0 point. It means that your starting point is not 0. Like temperature is an excellent example of that. 0 temperature means not absence, temperature is still there. And if you transform 0 centigrade to Fahrenheit or anywhere, you will find a number. And similarly, the IQ score, 0. If you got 0 IQ score, doesn't mean you don't have an IQ. And at the last, the shoe size. 0 means presence in this scale, and hence it has a drawback that we cannot multiply or divide the interval scale data. Since we cannot say that 40 centigrade is twice as hotter as 20 centigrade, because we can't divide. It don't have any true 0 point. And the most prime scale of measurement is the ratio scale of measurement, in which there is true 0 point. It has all the properties of the previous scale of interval scale, and plus an additional property that it has a true 0 point. So in this scale we can subtract, we can multiply, we can add, we can divide, because it has a true 0 point. Height starts from 0 and weight starts from 0. Age is another example of ratio scale. So this is the most prime measurement. So here is the end of the lecture.